Okay. Um, in this video, I'm going to show how we can create a simple thread in C#. I will walk you through the process of creating the simple thread. Towards the end, we will see what is the role of Thread.Join. So a thread is a lightweight version of your process. A process actually consumes resources. The resources are in terms of memory, files, disk access, etc. A thread is a lightweight version of the process. That means it can also access those resources, but it's a lightweight. It may do a simple task. Yes. So the CPU actually performs a time slicing to execute the instruction set in the process or thread. So when it is performing time slicing, it looks like the process or thread runs in parallel. Right. So it executes the instruction set based upon the time slice. Let's say in a modern operating system like Windows, the processor architecture support, the CPU architecture supports only 2 CPUs. And if there are 40 processors, we can't say that all 40 processors are running in parallel. It looks like they're running in parallel, but these 2 CPUs performs time slicing and executes instruction set in all those 40 processes, so that it looks like all 40 processes are running in parallel. Okay, right, that's a different story. We know that OS spans multiple processes. If you look at the old DOS system, the OS can span only one process, and once the process finishes, the next process can be executed. But in modern operating system like Windows, we call this as a multitasking operating system. That means Windows can span multiple processes, and CPU can execute all the process at the same time through its time slicing mechanism. OS can span multiple process, system or user, and a process can span multiple threads. So in this example, we are going to create a console application. So when I say console application, it's a process. A process is nothing but an executable exe, which is launched by the OS. Once OS launches, the process comes into memory, and CPU starts executing the instruction sets that presents in the process. Right. So as I already told, we are going to create a simple console window application. That means which is a process, and that process is going to span 2 threads. Right. So towards the end of the demo, we will see the usage of Thread.Join and in what situation we need to use Thread.Join. We will see that in the demo. So if you see here, there are 2 loops. The first loop is count var1, which runs from 0 to 1000, increments the variable in each iteration, and prints the variable to the console output window. After that, we are changing the console output window color to yellow. Then we're starting one more loop that counts from 0 to 1000 and it prints the number. In the right side, you are seeing the time consumed by the process. The red color mark shows that it's a main thread. The main thread first starts the count where one loop, which is nothing but this loop. So it starts counting the numbers 0 to 1000 and time taken for that is t1. Then second loop starts. That means once the first loop finishes, second loop starts, then it starts printing the variables. It starts printing the value in the variable. Right. First, let us examine this part. Okay, we opened Microsoft Visual Studio and I'm creating a project. So we have to choose console application. And this demo, I'm going to create thread using this console application. I'll choose location as temp. I will name this as simple thread. Okay, the console application is ready. So now let me build the solution. And if you can see, it creates a exe at particular location. As I already told, the exe is nothing but a process. So I'm copying this path and let's go to that path. Right, so the process is ready. Now we will start writing some code. Okay, let me minimize this. So if you see, this is a single entry, single exit system. That means in case of a UI application, the window gets launched and the thread stays in the background looking for the user interaction. But here there is no user interaction. Once you start the exe, the process loads into memory, then it enters the main. After that, it starts executing the statements one by one, then it exits. So there is one process here and there is one thread here, which is nothing but the main thread that enters here and leaves at the end. So here we declare two variables. One is count where 1 and another one is count where 2. After that, we are printing some console messages. We are stating that we are going to start two loops. First loop prints variables in green color and second one will print variables in yellow color. So press enter key to continue. That means here the read line, this function will wait on the console output window to read a line. So usually user, once they press enter button, uh, we are reading a line. Of course, they can type something and they can hit enter, but our purpose is to stay after printing this line so that user can read this instruction. After reading this instruction, if they hit enter button, the read line will execute, and it will return, and we will enter into the next statement. That means the main thread halts here. If you see why it is halting here, it is halting because of the user input which is given, which should be given in the console window. Okay, when I started this demo, I told there is no user interaction. Actually, here in the console.read line, we are looking for the user interaction. So the main thread waits here for the user interaction. All right. So once he hits enter, he or she hit enter, we are stating that main thread starts counting. Then it starts counting the variable, which is already explained in the slide. Then we are running the second loop and we start counting the second variable. Look at here. First we are setting the console window into green color so that we will see count where 1 0, count where 1 1, count where 1 2, like that. It runs till 999. Then the color is set to yellow and the second loop runs. So if you see here, the operation is sequential. Let me build this. Okay, and we will run that exe here. First I will put clear screen. Then I will type simple thread. So it says press enter key to continue. The instruction says loop 1 in green and loop 2 in yellow. So I'm going to hit enter now. And if you can see, the counting is done pretty fast. The first we counted all the way 0 to 999, and the yellow color shows that second loop started. And if you see, there is no mix. First the loop 1 finishes, then loop 2 starts. Okay, let me put clear screen here. If I put DAR, the color is in black color, default color. That is because we are making call to console.reset color. So after counting these two loop, we are setting the console window to its original state. That means once the program exits, the console window goes back to the original state. All right, now let's go back to the slide. Okay, we tested the example without thread, and you saw that in the console window 2 loops executed in sequential. There is only one thread, main thread, that started the loop 1. Then once loop 1 is ended, it starts the second loop. So the operation is sequential here because we used a single thread, and CPU time slicing goes for the first loop. Once it's done, then it starts executing the instruction for the second loop. Now let's go to the thread way. So here if you see, to use thread, we need to include a thread namespace in the application. Then here, if you see, I created first thread. To create thread, we need to use a thread namespace. Thread T1 equal to new thread. That means I'm creating a new thread. So this is the constructor. In the constructor, I am passing a delegate. The delegate is a Thread.Start. which expects a function that returns nothing, and which accepts nothing as a parameter. Yeah, here thread class refers a thread, then Thread.Start is a delegate. So with this above two information, we can start a thread. And if you look at previously, we used two loop counting in the main thread. Now if I see, I moved those loop counting to a different function. If you see, this is a static function, count where one thread, and which does the same, counting the running the loop from 0 to 1000 and printing the value. But the difference here is we are setting the console window color to green for the first function, and in the second function we are setting the console window color to yellow. That means whenever we print something through thread 1, the text appears in green, and when thread 2 prints that, in the console output the text appears in yellow. If you see, there are two threads which is served by the CPU in parallel. That means the CPU executes the instruction set present in thread 1 and thread 2 through its CPU time slicing algorithm, and both the thread try to access the same resource, which is nothing but our console window. So this is thread, and this one is a Thread.Start delegate, and we are passing this function as parameter to Thread.Start delegate. So once we start thread T1, then it makes a call to this function, and that function runs in thread T1 context. Similarly, the second function runs in thread T2's context. So the timing chart will go like this. Remember the previous screenshot, we saw that main thread starts running, it starts counting the loop 1, then it counts loop 2 by starting it. Now in this case, we are starting two thread. That means main thread will start T1 first. So if you see, the black color here is a time, T1, let's say 10 millisecond, 20 millisecond, 30 millisecond. That means time is moving on. Here our program starts, and after some point in time it starts thread T1. That means thread T1 starts running, main thread is running, T1 is running. So after some point in time it starts T2. So T2 is running at this stage. Look at the cursor location here. T2 is running, main thread also running, and T1 also running. After some point in time, thread T1 quits. That means the task of main thread is start thread T1, then start thread T2, because it's not doing the counting here. So the counting is dedicated to thread T1 and thread T2. T1 does the first counting and T2 does second counting. Previously we did both the counting in the main thread context itself. So since the counting gone to thread, main thread finishes earlier, right? But we won't quit the process, because OS knows that the thread T1 and T2 is child of the main thread, and main thread is child of the process. So since T1 and T2 is still alive, the process is alive. So the process is kept in the memory by the OS, right? So if you see, at some point in time, thread T1 finishes its counting, and after that thread T2 will finish its counting. So it's a racing condition. So in this illustration I had shown that T1 finishes first, then T2 finishes next. But if you run it multiple time, even though thread T2 is started second, the order may be different. That means T2 finishes earlier and T1 will get finished after that, even though it gets started first. So we can't determine who will win this race, but the point here is the instruction execution is going in parallel by CPU time slicing, right? So that's what I explained here. Main thread started first, then main thread starts T1 and T2. Yellow region, all threads running. That means at some point in time you can see that all three threads are running. That means main thread is running, T1 is running, doing its counting, count where 1, and T2 also running, doing the counting on count where 2. So after some point in time we can see that main thread is not alive, it's dead, and only T1 and T2 is doing its task of counting the numbers, right? Okay, let's see that with the example to get more light on it. So here if you see, first we have to remove these two counting function from here. Why? Because mine is not going to do any more counting. Next, I'm moving this function, that means these two counting, to a different function. Alright, now if you look at the example, we have introduced two functions. One is count where 1 thread and the other function is count where 2 thread. So these two functions are static. Why? Because we are going to call it from the main, which is static. Alright, so we added two functions here. Next we need to add threading namespace. Why? Because we like to assign the first counting function to thread T1, then second counting function to thread T2. So when this function executes, it runs on a thread, and count where 2 runs on another thread. So to use thread, we need to include the namespace system.threading. Okay, if you see here, first I put some instruction here. Let's start two counting loops in thread, then thread 1 in green, thread 1 in yellow, press enter, console.read line. So counting in loop is not required, so let me remove that. Sorry, if you see here, thread T1 is created, which is already explained in the slide. Similarly, we created a thread T2. Then we are making call to T1.start, then T2.start. Let's say that the main thread entered here. It start executing the statements. That means the instruction state. When it comes here, it executes instruction set for T1.start, then moves to the instruction set for T2.start. At this stage, When it is busy executing the instruction set for T2.Start, the T1.Start already started, and when the CPU time slice occurs next time, it may execute some of the instruction set in T1.Start. That means T1.Start will make a call to count where one thread. Why? Because that's what we specified here while we are creating a thread through delegate. So T1.Start looks for the delegate, then make a call to that function. Okay, let's go back to where we left. CPU comes here, it executes instruction set, which is nothing but calling the delegate, then spanning a thread and executing the instruction here. Then main thread won't wait. When the CPU time slicing occurs, it comes, and that means it may not execute all the instruction set for this function, this threaded function. Why? Because here the instruction sets needs to be executed repeatedly for 1,000 times, since we are running the thread from 0 to 1,000. That means after executing the instruction set for 2 or 3 times, the CPU time slicing occurs, and it knows that there is a main thread which also has some instruction set, and it starts executing that. So it starts executing the T2.Start. Then time slicing will occur for T2.Start, and time slicing should occur for T1.Start, and time slicing should occur for printing this console.write line also. That means when CPU executes instruction set for spend some time executing the instruction set for T1, then it will spend some time for executing the instruction set for T2, then it will spend some time for executing the instruction set for the main thread. So it all happens in the time frame or the time slicing which is allocated for our process. So when OS allocated some nanoseconds or some milliseconds for this process, within that millisecond it will allocate time for all these 3 threads, then it will switch to some other process which is in the OS. So after executing all other process instruction set, the CPU will come back to our process, then it will start treating all 3 threads, T1, T2 and main thread. Right, now let us execute this application and see what is happening. Before that, we will build this solution. Okay, it is succeeded, and if you see, I will start from here. Main thread executes this line, main thread executes this line, main thread creates 2 thread, main thread executes this line, so thread T1 starts and T1 executes this line, main thread goes to T2. That means at this time there are 2 threads, one is T1 and T2. Once main thread executed the instruction set for T2, then main thread comes here. That means at this stage there may be 3 threads, T1, T2 as well as main thread. Alright, after that we are resetting the color once 2 thread execution finishes. Yeah, let's examine this. Okay, I'm calling this simple thread. So we will end up seeing an instruction set. Okay, let me hit enter. We will see the other instruction set. If you see here, previously we saw that we printed all the counting, that is green color counting started from 0 and finished at 999, and here you can see a mixture. That means count where to count at 887, then count where it's printing 935, then count where 2 is running, then count where 1 is running. This proves that two functions running in parallel, or CPU is paying some attention for first thread, then it is paying attention for second thread, then paying attention for first thread. Like that it is going on. And if you see here, in this case, CPU paid attention for our second thread, then it executed the first thread 2 times. So if you go to a different location, and you can see the green is executed 2 times, and at the end, when green finished, the thread T1 finished all its counting, and you can see that there is only one thread which is alive, and CPU is paying attention for only that thread, that is T2. And if you see in main thread, we are making call to console.reset color. But if you see here, our console is not reset. We are still seeing the console window is yellow color. This is because if you remember the timing chart, main thread finished earlier. That means main thread started T1, main thread started T2, T1 and T2 is running, main thread is executing this, then main thread is resetting the color of the console window. That means it resetting the font color to white. But what happens after that, it executes this line, then it quits. But if you see, T1 and T2 still runs. That means in T1, T2, we are setting the foreground color as green, then the T2 sets foreground color as yellow. By looking at the output, we see that it printed 2-3 statements here, and by that time, it set the foreground color to yellow. And once thread T2 quits, there is no more instruction to execute, so the process is thrown out of the OS memory pool. And that way our console window is in yellow color. That means the thread T2, which sets the foreground color to yellow, that is the last instruction set executed. After that, we are living with that yellow color for the console window. Right, so let me close this console window and reopen it, and if you see it, now the color is reset back to white. Alright, let's go back to our slide. So we tested the example with a 2 thread, and we also saw that since main thread finished early, even though it tried to reset the console window color to white, the thread which is running even after the main thread is dead sets the color to either green or yellow. So if the thread T1 finished lost, then we may have seen the console window left with the green foreground color. So what we can do, we can ask main thread to wait for the thread T1 and T2 finishes its job. That means when we make a call to T1.join, we are making call to this T1.join from main thread context. That means main thread is making call to T1.join. So in this case, main thread will wait for T1 to finish. Then we are making call to T2.join. That means it will wait for thread T2 finishes its join, its operation. So when we look at these two statements together, main thread will wait for T1 as well as T2. So here we get two consequences. Let's say main thread T1 is main thread is waiting for T1, and let's say the thread T1 finishes first, then it will go to the next line and it will wait for T2 to finish. So once T2 finishes, then it goes to the third instruction set and resets the color, and that way we will be seeing the original foreground color before the application is started. That means we will see the white foreground color. The other consequence is, even though we are waiting on T1.Join, sometime T2 will finish first. So we will wait for T1.Join. So T1 finished its operation, so we will come to the next line, and when we come to the next line, we know that T2 already finished its job. But because here T2 finished first, then T1 finishes. So I'm discussing that scenario. So in that case, when it comes to the next line, since T2 already finished its job, so the main thread won't wait for it. Why? Because T2 is already done. So it will go ahead and reset the color. Okay, let's go back to the example and we'll make this simple change. Okay, here we are implementing the Thread.Join functionality. So after starting the thread, we are making call to Thread.Join, and now the build process created a exe, and we'll go ahead and run the application. So I'm copying that text. Let's go to so this time you can see once the thread operations are finished, we will default to this original foreground color. That means here we are starting our process by typing simple thread. It's a exe. So in the command prompt will launch that exe, and it is printing this instruction set. Once I hit enter, it spans two thread, and those two thread try to access this console window, and they will change the foreground color. So it's going on. So once it is finished, you can see that main thread after counting loops, and we are seeing the color is reset back to white foreground. All right. So there is some thread synchronization concepts also exist. Sometimes if you see, this is a good example. Count where 1, which shows this in green color, but count where 2, it should have printed this in yellow color, but it still prints this in green. So there is it's kind of an error here, right? So this is because, let's say we are talking about CPU time slicing, right? Let's say the CPU executed this line or instruction set for this line, then the time slice occurred and it gone and served the second thread. So when I try to serve the second thread, let's say previously it left the instruction set of left with the instruction set of printing the value here. So in that case, the previous instruction set executed is from thread T1. When it jumps to thread T2, sometime it may be possible to execute the instruction set for this one. That's why we see in green color thread T2 printing its count. or in yellow color thread T1 is printing its value. So here we can do some synchronization to make sure these two instruction set will get executed together, then it will move to the next one, or we can lock these two statements. So that's altogether a different concept, and we will see that in next coming videos. So that's all. We saw that reset color is happening perfect now. We executed, we tested the Thread.Join. So that's all in this demo. Thank you for watching. Goodbye.